Okay, good morning, everyone. As usual, do you guys have any questions about the homework? Please put them on chat while I wait for everybody to join in. Okay, so I recap a little bit what we did last time, and I would like to do one problems. So last time we studied quadratic functions. So, okay, we studied functions that have the specific format ax squared plus bx plus c, those type of functions, where a is non-zero, absolutely non-zero. And then we talked about the graph, and the graph is, this could be depending on a positive or a negative. So if the graph, if a is positive, the graph go up and go down. Sorry, my apology. If a is positive, it's concave up. That's a positive. And if a negative, is concave down. And then we've talked about the vertex. That's what characterizes it, the vertex. And the coordinate of the vertex, so x coordinate, was minus b over 2a. And the y coordinate, you just plug in the value of the function at this point. Okay, that's the vertex. So that's the vertex. So it means this right here is minus b over 2a. This right here is minus b over 2a. And then we've talked about the zeros. The zeros are where the function takes the zero value. So these are what we call the zeros of the function. So these are the zeros. Okay. So to find the zeros, what all values of x, where the function takes the value 0. That's really what the zeros. And then to solve, to find zeros, we set basically, if it is quadratic, if this is the formula, equal to 0, and we solve. And what we said last time, that to solve, we usually factor. If we cannot factor, I mean, if we can't, we look at it and we cannot factor, and we have to use the quadratic formula, which tells me that we have two solutions, minus b plus the square root over 2a. So that's a summary of what we did, minus b minus the square root of that. Okay. All right. So I'm going to do one problems and then proceed. Okay, so I will do the following problem. Please, if you have questions, go on, ask. All right. So one of the problem I've assigned, and from next time I'm going to assign more problem, is like number 17 in the book. I'm going to do that. I'm going to elaborate a little bit more on it. So let me read the problem. I'll put it in front of us and read it. Okay. So this is my problem. You take an object and you throw it. Okay, so you have an object and you throw it. And the height of the object above the ground, t seconds after it has been thrown upward, is given by the function f of t equal to this. So that's the formula. The question number 17 is determine when the object hits the ground. So we're going to do this first. So what is the scenario? So we have an object, basically. Any object, you throw it, the object goes up, and then the object will goes down. That's really what's happening. And f of t is the formula that will give you the height at every moment of time. So this is minus 16t squared plus 50t plus 200. So f of t is the height of the object t seconds after we throw it in the air. Okay, so this is the function that tells you, at every moment in time. Those are very, very typical functions from physics. For those of you who will take physics, you will actually understand where this formula is coming from. So f of t is the height of the object t second after we throw. So we take it, we throw it, and the function tells me, okay, at every moment in time, what is it? What is my object above ground? Okay, so the question is, okay, when you take it, you throw it, comes back, it's going to hit the ground at some point. The question is, when does it hit the ground? All right, so I will draw something. I'm going to draw the function f of t. F of t, that's the graph is parabola. Parabola going down because a is negative. And that's what we expect. So this is the time on the horizontal. And this is the height here. So this is the height. And of course, the ball starts somewhere. The height is going to increase, it's going to hit a maximum value. And then we know that the ball is going to go down and down and down, hit the ground, back again. Okay, so that's really the graph. So this tells me the height. The question number one is, when does it hit the ground? How can I do that? Back to you. You guys are too quiet right there. So the question is, when? That's the first question, because I'm going to add one. When does the ball, or when does the object hit the ground? Okay. F of t is the height of the object above ground. All right, back to you. How can I find when does the object hit the ground? How should I do that?
Wouldn't we try to find the zeros by either factoring or using the quadratic formula?
Exactly. We're gonna, because the object hit the ground when the height is 0. So we're gonna set f of t equal to 0. Solve for t. Basically, we're finding the 0, as your classmate said, rightfully so. So it means we have to set minus equal to 0. All right. Now, do you think we can factor this expression? What do you think? So we have to solve. Whenever it's quadratic, we need to solve. We have to make sure one side is absolutely 0, which is in this case. Now, how can I solve this? Do you think there is any hope you can factor that? Yes or no? Anybody? Can you guys hear me? Hope so. Okay, so we're going to use the quadratic formula. Okay, there is no way we can factor. The a here is minus 16. The b is 50. And the c is 200. So to use the quadratic formula, I need to evaluate b squared minus 4ac. So just to make things a bit easier when I use it. So this would give me 50 squared minus 4 times minus 16 times 200. All right. So how much this would give me? Equal to what? So plug in this into our calculator. 50 squared minus 4 times 16 times 200. So I'm getting this huge number, 5300. Okay, so now what are the solutions? So we have definitely two solutions. Okay, one is minus b plus the square root over 2a. And the other one is minus b minus the square root over 2a. So we have to compute each one of them. Let's compute the first one. Minus b, it means minus 50 plus the square root of that divided by 2a, it means 2 times minus 60. Now, because the square root here is really a messy number, we're going to use our calculator to compute the whole thing. Okay, so I'm going to compute that on my calculator, and you guys can compute it yourself. So see if you're using it correctly. So get going and put your answers on chat. See what you guys come up with. So it's minus 50 plus. Okay, anybody got anything? Any answer from anyone? Okay, I don't want to be start calling on you. So please give me whatever you got. What are you getting? What are you getting for answers? Minus 1039, it can't be, because did you divide by 2a? Because it's time. The time cannot be 1000. Did you? Okay, then there is something not right. Let's do that. Let me do it. Okay, so it's minus 50. Sorry. Minus 50 plus, so you do it the square root of 15, 0, 0. That's my numerator. And I'm going to divide this by 2a. It's minus 32. So I'm going to divide it by minus, sorry, divided by minus 32. Oh, sorry, I messed up. Okay, I'll do it again. Minus 50 plus the square root of 15300. That's the numerator. Divided by.
You have the answer in a part of it, so it screwed up the number.
What?
You have the answer minus 50 plus the square root, so it screwed up the answer.
Oh. Okay, I was wondering what I'm doing wrong. Minus the square root of 15300 divided by minus 32. So I'm getting minus 2.3. So Jay, can you please check that why you got minus 1039? That's why I want you to do it, okay? All right, very good. Now this is a negative answer. And t represents time. So this one we cannot accept, all right? Because t represents time, and this is minus 2.3, so that's not the value that we want. Now we're gonna compute the second one, and you guys tell me what you get for the second one. Over 2 times minus 16, all right? How much did you get for the second one? And that would be the time we need. So I will do it with you. Okay, all right, I'm getting 5.421 seconds. Anybody got that number? Anybody else? Okay. 427, yeah, 43 will be, but I will accept that. Anybody got that number? All right, so just plugging in, and this would give me the time. So this time here, this is right here, is after a little bit over 5 seconds, the object will hit the ground. Okay. Now question number 2, which is not number 17, but I will actually want to add it to the problem. Suppose I tell you this point right here. What does this represent? First of all, what's the value here? And what does this represent? So this is when the ball, the vertical intercept, when the graph intercepts the x-axis. What's the value here and what does it mean? Exactly, the value is at t equal to 0. So the value here is 200. Okay, and the unit of the height, the height of the object above ground in feet. The unit is feet. What does this 200 represent in terms of the problem? What does the 200 represent? Back to you. So the 200 in this problem, what does it represent? In English, I mean, how would you, the height at the starting point, exactly. 200 is the height when t equal to 0. It means when we throw the object, the minute we throw it, we were 200 feet above ground. So that's the initial height, if you want, or the height at t equal to 0, it was 200 feet. My last question is, when does the ball, that's not in the problem number 17, but it's in other problem, at what time or when does the ball hit its maximum height? So question number B that I'm adding to 17 is the following. When does the ball or the object, when does the object reach its maximum height? When does the object reach its maximum height? So you're taking this object, throwing it up, going down. At some point, it reaches a maximum height. And the question is, when does the object reach its maximum height? And what is, for now, it's when. So how can I find when does the object reach its maximum height? So that's the function, that's the graph. What shall I do? Please quickly, we have a lot to talk about. The height, okay, so when does the object? So that's the height. Initially, 200 feet above ground, we throw it. The object goes up, down, here. So if I want to find when does it, what do I need to find? I need to find exactly this point here, the vertex. So it reaches maximum height at the vertex. So now how do we find the vertex? So the t is equal to, the maximum height is obtained at the vertex. It is obtained at the vertex. So to find it, I need to find the horizontal coordinate of the vertex. This is equal to minus b over 2a. So this is minus b over 2a right there. So it means minus the b is 50 over 2a, which is minus 16. So now minus, so it's 50 over 32. Now if we simplify a tiny bit by 2, both sides give me a 25 over 60. Okay, so this point here, which is almost 25 over 16, just to have a feeling, because I'm talking about time, it means about, if we divide them, about 1.56 seconds, almost that much. Okay, it means it reaches maximum height. You throw the ball at some point, it reaches maximum height, and the maximum height it's obtained after 1.56 seconds almost. Okay, so this time I went decimal to give you a feeling of the time. So 25 over 16 is almost 1.56 seconds. And the last question, the natural last question would be, what is the maximum height obtained by the object? What shall I do now? So what is the maximum height? Back to you. I give you a minute to answer the question and give me everything. What is the maximum height? So we know when it hit. How can I find the maximum height? Okay, I'm getting some answers. Anybody else? So what I need is, the maximum height is obtained here. I need the time. I need what here. So we just plug in F. Exactly. We just plug in F at 1.56 and I evaluate. So it's going to give me minus 16, the squared, plus my function was 50t, 50 times the input, plus 200. Okay. And if we do the math and we do everything, we get, anybody did it? Almost 263.476 feet. You just plug in into your calculator and you get that much. So that's the maximum height found by the ball. Okay. So one of the most basically important examples of quadratic are actually those types of problems, because as I said, those are real problems. The formula come from physics, and actually in calculus, you also go through this formula, and that's represent us. You take an object, you throw it, it comes back, and this is the nice formula that gives you actually the height, and it depends on how initial height. So when you throw it, so usually this number here is the height that you threw the object from. And this 50 here also has a meaning, which will be the speed at which you initially throw the object at. Okay. Can I see when it would be on the ground? Yeah. This piece. All right, any questions before we move on? All right, so now we're going to move on basically to chapter 3, which is exponential function. But before I move on to exponential function, I have a little bit to remind you exponent. So we need to work with exponent. So today what I'm going to do is a quick review of exponent. And next time we start studying chapter 3, which is exponential functions. Esmeralda, are you done? Esmeralda? Yes, thank you. All right. So today I'm going to do a review for exponent, which is crucial for us. All right, so review of exponent. Like we did a review of fractions, now I'm going to do a little bit the review of exponent. All right, so before review exponent, I'm going to review something that I know that you know because I've worked with you, but for my own peace of mind, I want to make sure you know it. The idea of nth root. All right. Suppose I write the square root of a. Okay, let us remember what the square root of a is. The square root of a is nothing more than the number, the positive number. So it's the square root of a is the positive number. That's 1 raised to the power 2. Give us a back. 1 raised to the power 2 gives a back. Okay, so the square root. No, the exponent will be on your exam next week, not on the quiz today, definitely not. So what's the square root of a? So the square root of a is the number such that when you take this number and you square it, you get a back. Okay, that's the definition, the simple definition for the square root. And it's the positive number, and why we need the positive number. So very simple example. The square root of 16 is equal to 4 because when you take 4 squared, you get 60. Okay, but here I would like to make a remark. There are two numbers, when you square them, you get 16. You take 4 squared, you square it, you get, and you take -4 and square it, you get a 16. But by definition, the square root is the positive one. So even though -4 squared is 16, the definition of the square root is the positive one that gives you, when raised to the power 2, gives you 4. So even though there are two numbers, the definition of the square root tell you is the positive one. Now, again, the cubic root. The cubic root of any number is the number. There is no more positive here. Is the number when raised to the power 2, to the power 3, gives a back. So these are stuff that I know that you know. So what's the cubic root? It's the box, that's a number, so that when you take it, you raise to the power 3, you get a back. Okay, so if I compute, what's the cubic root of -8? And now I want answered, and I want them very quickly. What's the cubic root of -8? It means what's the number? When you raise to the power 3, you get -8. Very quickly.
2.
2. Are you sure?
Yes, because.
Are you sure?
Wait, to get -8? Oh, it'd be -2.
-2, yeah. -2. Now watch very carefully. Under the cubic root, I can have a negative number because -2 to the power 3 gives me -8. Under the square root, I cannot have a negative number because there is no number. When you square it, you get something negative. So under the cubic root, negative are allowed. Under the square root, negative are not allowed. So in general, what's the nth root? N, but we're going to find the definition in general. The nth root, what shall I put n here, is the number when raised to the power n gives me a back. Gives a back. So the nth root of any number is the box, this is the unknown, that has the property when you take the box, you raise it to the power n, you get a back. So there we have the third root, the fourth root, the fifth root, and so on and so forth. So very straightforward example as usual. Suppose I tell you find the fourth root of 81. It means I'm asking you, what is the number when you take it to the power 4? Of course, I'm giving you easy numbers. Otherwise, you get 81. Can anybody figure it out? Which number do you think when you take it to the power 4, you get 81?
3.
3. Absolutely 3. Because 3 to the power 4 is equal to 81. So that's the idea of fourth root, fifth root, 100th root, no matter what it is, that's the definition. Now, some of the properties of the algebraic properties of the roots. So some of the algebraic properties. Sorry. First property is that if I have the nth root of the products, if you have two numbers and you have a multiplication between them, then we can actually split the product. So this is correct. So there's some of the algebraic properties. Also, if you have the ratio A over B, this also could be split between that. Okay, so when I have a multiplication under the root, I can split. When I have a fraction under the root, I can take nth root of the numerator over the nth root of the denominator. Now, properties that do not work with the square root. Okay, what's not true? Not true is that if you have a sum under the square root, I cannot break the sum. So we cannot break the sum, but we can break the product. It's very important because that's a very, very common mistake. So for example, if I take the square root of 4, let me take the easy number, 9 plus 16, this is not the square root of 9 plus the square root of 16. I cannot break the square root if I have a sum under it. I can break it if I have a product, because watch carefully. 9 plus 16, that's 25. So the square root of that is equal to 5. Square root of 9 is 3. Square root of that is 4. So they are definitely different from each other. So we can break product, we can break a fraction, we cannot break a sum. So I'm going to give you two simple exercise where we're going to use a little bit this property. So my question is simplify so that no roots remain. So that I don't want any more, no roots remain. So let us say cubic root of a to the power 3. This equal to what? And we're gonna justify that. Please, I want answers because this is algebra that you've seen before. So I want quick answers. And you do a lot of mistake with them. What's the cubic root of a to the power to a3? Just a. Absolutely, don't be afraid. Because what's the cubic root? It's the number. When you cube it, you get what's inside. So you just take a cube. It's going to give me a cube. So cubic root of a to the power 3 is just a, because that's really the definition. It's what's the number? When you take to the power 3, you get a cube. It's a itself. All right. I wanted to simplify this. Okay, so that, no, it is plus a. It's not minus a, because why it's not minus a is wrong. Because if I take minus a to the power 3, what do I get? Do I get a to the power 3? If I take minus a, I will get minus a to the 3. And the idea is you want to get a to the 3. So this is absolutely wrong. Go back to the definition. Always go back to the definition. All right. Now, what's the cubic root? Sorry, the cubic root of 8a cubed. I want you to simplify it so no roots remain. And you can use the property that I've mentioned. So you can use those properties to break things up. All right. Let's see. I can break it because that's a multiplication. I can break that. So it's the cubic root of this, of 8 times this. Cubic root of 8 is a 2. Cubic root of that is a. So that's equal to 2a. So once we use the property, it becomes a bit easier to satisfy. Now, what is the cubic root a6? I want you a little bit to think about it. Okay, I give you a minute. All of you, I don't want only one student. I want all of you to be able to interact with the problem. And I put 6 for a reason.
Professor, I have a quick question about our second exam. That's is it next week?
About what?
The exam that.
Yeah, it's next week. We talk about it on Thursday. Yes, now focus on this. Yeah. Because this will be on your exam. What's cubic root of a6? And of course, why? Anybody? A squared. Jake, why it's a squared? Can you give me the reason? Because I want the reason from you guys, not from me. Jake, can you talk?
Yeah, okay, so I believe it's a squared because, well, 3 goes into 6 2 times. So if you have the square root of 8, if you have the cubic root of a6, it would end up being a squared. 6 divided by 3, that's 2.
Okay, we're gonna do that. Okay, so your classmate is telling me, basically, is telling me the following, that A6, 6 is 2 3s, right? So A6 is that. Am I correct? If I take A3 times A3, how many A's I have? I have 6 of them. Okay, so this will give me cubic root of this times the cubic root of that. A times A, which is A squared. Or whatever you were taught back in high school. I don't know how you taught this stuff, but this is really A squared. But that's really the most obvious reason to that. So it's A to the power 2. Okay, Naki, actually, wait, it would be, no. 6 over 3, Naki. You were right the first time. So it's going to give me A squared. All right, so now the last one I will give you again is the following. I want you to simplify before I move on to powers. I want you to simplify the following, and I don't want any cube to remain. The square root of x squared y4 over 4. Again, I want this to be simplified. Please, I want all of you to pitch in. I'm glad some of you are. I want the whole class to give me an answer. And use the algebraic property for ease. Use those algebraic properties because they are actually helpful for a lot of us. Anybody else? Okay, let me pick somebody. Okay. Ricky, are you with me? Ricky? I guess not. I move on. If Hussein doesn't answer, I just move on. Oh, yes, okay, what's your answer? Okay, because, so I'm gonna split it into x squared y4 because we can do that. And this could be split, square root of x squared, square root of y4 over 2. Now, square root of x squared is x. Square root of y4 is y squared over 2, and of the problem. Okay, so these are the nth root. Now we're going to start introducing, and some of you seems to be a little bit familiar with that. We're going to start introducing exponent. So exponent. So the first part was review of the nth root. Now exponent. First, suppose n is an integer, n. A to the power n, the one we know, is basically, so let's assume n is an integer. Okay. A to the power n means a times a times a n times. Of course, all of you know that. So 2 to the power 4 is 2 times 2 times 2 times 2, which is going to give me 4 times 4, which is 60. Okay. Now a to the power 0, anything to the power 0 is always 1. So anything to the power 0 is 1. A to the n is a times a times a. Now, negative exponent. Negative exponent. What does a to the minus n means? So that's the definition. So when you're going to have a negative exponent, what does this mean? Okay, so negative exponent. All right. Anybody tells me, what does a to a negative exponent means?
You would just multiply by the negative version of that number until how many times it has for the exponent?
I don't think I followed. So let me take an example. 2 to the minus 3. What does this mean to you? Have you ever seen something like that?
I haven't seen a negative exponent in a while. I don't think I've even seen one before, but wouldn't you just do times -2 times -2?
No. It's 1. That's now
Wouldn't
you have
do
to learn
1
it. It's 1 over
1 divided
2 to
by
the power 4.
Oh,
Okay, crucial. That's why I'm reviewing this. It's 1 over a to the power n. Crucial. Okay, so if the exponent is negative, this means 1 over a to the power n. So for example, now we're going to put all those in red because they are very important to know. So for example, 2 to the minus 3, negative exponent means exactly 1 over 2 to the positive 3. That's what it means, 1 over 8. Okay, let's take another example. 4 to the negative 1. This means what? According to my definition, if the power is negative, that's negative power, that's negative power. This is what? This is 1 over 4. Okay, so let me take another example. Suppose I give you 5 to the negative 2. Taylor, what does this mean? What does this mean? Taylor, are you with me? No. Let's use this verbatim. What's playing the role of A in this scenario? What's playing the role of A? 5. What's playing the role of N in this scenario? What's playing the role of N in this scenario? 2. So definition is 1 over 5 squared. It means you bring the 5 down and you make the negative positive. So it's 1 over 5 squared. So the n here is the 2. So 1 over 5 squared. All right, I'll give one more and then I will proceed. Suppose I give you, I don't know, 8 to the power minus 4. What does this mean? Taylor, can you get that? One over 8 to the negative 4. What does this mean? We're defining it. We're giving it a meaning. That's what it means. So if you see a negative power, you should know what it means. What does 1 over 8 to the negative 4 mean? 1 over 8 to the positive 4. Okay, so that's really what the negative exponent really means. Because we're going to encounter them in chapter 3, we have to know what really they mean, the negative exponent. So it's 1 over 8 to the power 4. So here, the a is the 8, the n is the 4. 8 to the minus 4, it means you take the 8 with the positive power and you bring it down. Now, another important, there are two important. One, fractional exponent. So an exponent, which is a fraction, what does this mean? So I have a, so this is very new, this is definition. Not minus n, something like 1 over n. 1 over n. What does this mean? So a to the 1/3, what does this mean? This means the nth root of A. Okay, so this is, I'm gonna give you a paper with a summary of those crucial. So A to the 1 over n, so do not confuse minus n, like it's -3, -1, -2. That's A to the 1 over n means the square root, the nth root of A. So let's practice this a little bit. So for example, 16 to the power a half. According to this, what does 16 to the power a half mean? Definition. It means this piece in the denominator is basically the root. So that's the square root of 16, which is equal to 4. So 16 to the power half is equal to 4. All right, let's try another one. And now I want all of you. What is 81 to the power a third mean? So it's 1 over 3. The definition tells me it means that the piece in the denominator, there is a denominator here, this is the root. The denominator is the root. So that means the cubic root of 81. Okay, so a to the power a third, it means the cubic root of 81, all right? Which is, it's not a nice number. The cubic root of 81 is not a very nice number. So let me give another question. Suppose I give you 64 to the power, actually I don't want that, 32 to the power a fifth. What does this mean? Again, what's in the denominator, that's the root. So it means that it is the fifth root of 32. It means the number, which number? Take it to the power 5, you get 32. Now, if we think a little bit about it, this is an honest to goodness 2, because 2 to the power 5 is equal to 32. Okay, so that's a fractional exponent. So let's not confuse two things. 1 over n versus minus n. If you have a negative exponent, is 1 over a to the positive 1. If you have fraction, 1 over n is the nth root of a. And now the last one, the hardest one. Sometimes we have something like that. A, what do we mean by that? Well, the exponent is a fraction, m over n. And the question is, what does this mean? I mean, what does it mean? A to the power 2/3. And now let's see what this means. It means the following. Watch carefully. N is the root. So this is n. Let's give me the root. It's a, the whole thing to the power m. Or, and I will explain in an example, or, which is just the same thing, or nth root a to the m. So the m, you can put it outside the square root, the nth root, or you can put it on the a itself. It doesn't really matter, you get the same answer. So let us practice this a little bit, okay? We're gonna practice that. And there is no more. I mean, these are all the type of exponent that you will need. Negative exponent and fractional exponent. What matters is really to be able to manipulate them. And the denominator is always the root. The denominator is the root, and this is the power. Okay, so to help us really memorize those. So let me see example, and please do your best, all of you, to answer this question. So I want you to evaluate without a calculator. I mean, the calculator can do that easily, but if you do it with a calculator, you will not understand what is really going on. So I don't want a calculator because this is easy. The calculator is easy. I want you to evaluate without a calculator. 8 to the power 2/3. It means first, I want you to write it as using the definition. And once we do that, we evaluate. So step number 1, I want you to use this definition to write it. What's 8 to the 2/3? So I apply the definition verbatim. The denominator is the root. That's the 3. 8. And the numerator is the power. So that's step 1. So without simplification, I want you to write it using the idea of a root. Once we do that, a lot of time it will become easy. The cubic root of 8, it means the number when we take to the power 2 is actually a 2. Then I will have 2 to the power 2, which is equal to 4. So 8 to the 2/3 is actually equal to 4. So it's the cubic root of 8. So the denominator is the cubic root and the whole thing to the power 2, which is going to be equal to 4. Okay. Now watch. Let us say if I had taken, instead of taking the power outside, I take it inside, it's give me the same answer because the cubic root of a square is the cubic root of 8 times 8, because that's what a square is. Now the property of the cubic root will allow me to break the multiplication apart. So this is the same thing as the cubic root of 8 to the power 2. Means whether you put a square inside or outside the parentheses, those give me the same answer. Right. Now I'm going to give you another one, and please see what you can do with it. Suppose I give you 81 to the power 3, 4. Step number 1, I want you to write it to me using the root notation. So you guys write it, then I'm going to ask one of you to tell me what you did. And then we evaluate. But first, we're going to write it using the root notation to make sense out of it. So I want you to reconcile what I gave you with that, and then evaluate. Okay. All right, let me pick somebody. Jillian, are you with us? Jillian. Okay, I just move on usually when the student doesn't answer. Kyle, I don't think I'm pronouncing your name correct. I never do. Kyle. How can I pronounce your name correctly? I feel I'm not doing it right.
Kale.
Okay, Kale. Sorry. All right. Then what to write?
So do square root of 81 to the 4th power.
No, no. Let's watch carefully. That's why I want you guys to do it. What is the root? M over N. The denominator will be the root. What am I trying to tell you? What's the denominator here? 3 over 4.
4.
4. So what's going to be the root?
4.
4. That's the 4th root. Are you with me? Okay. Raised to which power?
3.
The numerator to the power 3. Okay? Now this is equal to what? Kyle, you can stay with me. Do you know what's the 4th root of 81? I mean, of course, I'm giving you easy stuff here. What's the number when you take to the power 4, you get 81? So what to the power 4 gives me 81? Anybody? It's actually 3. Because 3 times 3, 9. 9 times 3, 27. 27 times 3 is equal to 81. So this is going to give me 3 to the power 3, which is 27. I'm going to give you one more. before we move on to the quiz. So suppose I give you the following. Again, I want you now, I don't care about the answer, I want you to write it correctly. So suppose I give you, I'm gonna make up something, 75, let us say, to the power 2/5. I don't want the value, I just want you to write it correctly using the root notation. So I give you a minute and I pick one of you to write it for me. I don't want the value because it's not a nice number. I just want this piece. Okay, I'm gonna pick one of you to do it. Okay, Peyton, are you with me?
Yeah.
Okay, I want you to write it using this root notation. What does this mean?
I'm not sure how to like pronounce it. Instead of squared or cubed, it would be to like the fifth power. Would it just be
No,
fifth root?
no, it's not fifth power. When you say fifth power, it means you are raising it to the power 5.
Okay.
Is this what you want?
No, I don't know how to say it.
Okay.
Would it be fifth root?
Fifth root.
Okay.
So what do you want me? Oh, go ahead.
Fifth root and then 75 squared.
Oh, so this is the fifth root.
Yeah. And
The
then
5 goes
75
there,
squared.
and square. Now you can either write the square out or it's the same thing. I mean, it's the same answer or that. Either one, this is this exact mathematically, it's the same thing. It's absolutely the same thing. So the denominator is the root, the numerator is the power. Okay, so that's really what the fractional exponent is about. All right, so for next time, I'm going to give you a homework. The homework will be from previous old section, not like section, I don't know, 1 point something. So don't, but please make sure to do them, to practice this notation very well before I move on to chapter 2. Okay, now get going, start your quiz. And for the quiz, no answers from the calculator. Everything you have to show me where you got it.